Hi everybody, welcome back to Database Management System Presentation Series. This is Satyadev, VNR VJET, CSC Department. So in the last presentation, I talked about history of DBMS and the important people or pioneers of various DBMS concepts and stuff like that. Now in this presentation, we are actually getting bit deep into the databases. So I'm going to cover an important topic called data models. Now, let's just go to the next slide. So, what is a data model? Data model is nothing but a collection of conceptual tools for describing data, data relationship, data semantics, consistency constraints. Now, I think apart from data, the other three, words or other things are kind of difficult to digest if you don't know anything about DBMS. Data, we already seen what is data, but data relationship, data semantics, consistent constraints are something that is new. I'm going to explain more about this in the later presentation. Just to give you a brief understanding, data is nothing, we've seen data, right? Data is the raw facts, like facts that we get from doing an experiment. What we get is the data. Say for example, I'll take the example that I took in the first presentation. Students are coming in. There is a front desk where they are collecting the student information, student name, and their EAPCET rank and the marks they got in maths, physics, and chemistry. Right? That's pretty much what they are getting. Now, and their mobile number. Now, one student came in. So the front desk guy asked, "Okay, what is your mobile number?" Wrote it down. Then name, wrote it down. What are your maths marks, physics marks, and chemistry marks? Wrote it down. Then what is your EAPCET rank? Wrote it down. Now this is data, right? So these are all the facts because this guy's name is a fact, phone number is a fact, EAPCET rank is a fact. All these things are. This is data. Now if you see all these things, they are all connected to one person, right? So these are connected. And let's say there is another student that has come in, he or she also will give the same provided data. Now, once these guys are stored in the database and they are admitted into the college, they will be given roll numbers. For these guys will be given roll numbers for their respective classes. Now, that's going to be stored in another place. But that roll number and this data are kind of linked together. The same person, but the EAPCET rank, EAPCET, all these phone number may not be needed. But the roll number is an important aspect that has to be tied with this data, or maybe phone number or a roll number, whatever it is. We need to have information that needs to be tied. That means the actual data of the person, his course in EAPCET and all these things is one data object, and his details in the college, like which class, which section, or roll number, all these things. Name could be slightly modified, maybe shortened or whatever it is, right? So lengthened as per the record. So that's in another place it is stored. So but these two are related to one person, right? So that's the relationship. So we'll discuss more about this later. Then data semantics means meaning. Now when you look at the front end, when one person comes in the data, they're all giving you an idea of, okay, this is a student whose EAPCET rank is this, he got these many marks. So it gives you an idea about, okay, how can this guy can be admitted into the college or not based on when you compare with the other ranks. So that gives you some meaning. So basically semantics means some meaning, or giving some perspective on this thing. That's called data semantics. Consistency constraints. Now again, it's a big terms. I'm not going to go very deep, but basically, let's say this student has come in. He's telling okay, what is your mobile number? He told his mobile number, but he only told 9 digits. He forgot to mention another digit, or maybe the guy who is recording forgot. Then he looked at, hey, you only told me 9 digits. It should be 10 digits, right? Mobile number should be 10 digits. Oh, okay. I think he repeats it, right? So now why this is required? Because there is a rule that mobile number should be 10 characters, right? So 10 digits. So if somebody is not providing that way, I think then it's wrong, right? So that rule is called the constraint. So, and again, everybody should have 10 as the constraint. So this makes this phone number more valid, right? So that again, you can't have alphabets in the phone number. Similarly, you can't have, special symbols in the marks or ranks and stuff like that, right? So if you apply some rules in order to maintain the consistency of the data, make sure that we don't get erroneous data. That's called consistency constraint. So basically, data model is nothing but various tools or the way in which we represent all these things like data, relationships, semantics, and consistency, and defining them is called the data model. It's a philosophy, or it's a way of defining them. Well, there could be several data models to represent the same thing. For example, if you take the student data, you can store the student data in a comma separated format. So get roll number, mobile number, name, 10, whatever it is, like rank number 3444, then maths marks, physics marks, chemistry, comma separated, right? That's one way. Another way is you can put all of them in one, like for everyone you store like this in a linear way, right? So in a vertical way, right? So there are, or you can store all the, there are different ways you can store stuff, right? So depends upon how you store or how you manage like all these four things. You call that as a data model. There could be, like I said, there could be multiple data models. Each model, but all the data models does the same thing. Like they describe this data, relationship, and semantics and constraints, but they have their own way of doing things, right? So they're, it's like you from Bachpalli to Kokatpalli, you want to go, right? There are like 3-4 routes. The destination is same. You go in multiple ways, right? That's pretty much what each way is called one data model. That's pretty much what is data model. Data model structure is the way in which data model is organized, connected, and represents inside the database. So basically, when you implement the data model, that becomes a structure. That's pretty much what a data model is. Now, if you look at historically, there are several data models. I'm just going to mention all of them, but most of the important data models which we are going to discuss in the presentation series are relational and ER models, entity relationship models. So, but again, we will mention those things and we'll see relational models. So again, this is the most popular model until early 2000s, and even now it is popular. It's not like we are completely away with it. Relational models are still there. Many organizations they use, and we can't even obsolete because this is an essential thing. So relational models, they store data in tables with rows and columns, and they identify relationship using keys. All that stuff. They are also called as record-based models. Basically, like I said, most of the whenever you get data, the initial intuition is to store the data in relational model only. So that's the reason it is very, very popular. Like COD has, as you discussed in the previous presentation, made this relational model very, very popular. So examples of like SQL Server, Oracle, MySQL, Postgres, most and like I said, Clipper, all these things comes under relational model. So that's the relational model. Then ER model, entity relation model. This, to be honest, is not like storing data. A relational model using, we have databases like Oracle database, MySQL, we can create Postgres. But this is more like for designing, conceptualizing the data model. This is not to store or do anything, but this is to conceptualize the data model. So the way it works is you get the data, raw data, then you create ER diagram on top of that using ER model, entity relationship model. Then you convert that into relational model or NoSQL model, any model like any other model, and implement that. So basically, it is for using a design kind of the conceptual model. It represents real objects as entities and relationship. This is used before implementation, but there are software that using which you can create ER models like Workbench, which is from MySQL, Erwin, Oracle SQL Developer. These are some of the examples of interrelation model. So what we are going to do in this presentation series is in order to build databases, understand and learn designing databases, we first build in using ER model, entity relationship model, then we convert it to relational model. That's how what we are going to do. On top of that, there are other models which are called object-oriented models. So there are object-oriented programming like C++, Java, .NET, so Object-C. There are several object-oriented programs, right? So what they do is they create objects, basically. But these objects are only in RAM. These are created by programming language. Now you want to store that object as it is in memory, in the hard disk for later retrieval. That means you run normally the objects created by a programming language, they will go away as soon as your program is down or is closed, right? But if you store the data somewhere and again retrieve the entire object as it is, right? So that's like it is called serialization basically. So they are called object oriented programming language. So object DB, DB4O, Gemstone are the examples of object oriented things, data model. Object relational data model, both look similar but they are not. So object relational model, the behind the scenes, the database model is relational database model only, but when an object-oriented programming language interacts with relational model, it thinks that it is storing objects, but in fact, it is storing the relational, it's storing data in tables and columns. Whereas when you compare object-oriented, you have a student object. The entire student object is stored in the database as instead of storing, it's called serialized in the database. So whereas when it comes to object relational model, you store the object-oriented programming language think the student information is stored as an object, but it is actually not serialized. It is actually stored. That means it is divided into like name field or roll number field or marks field, whatever it is, right? So stored in the relational model. So behind the scene it is relational, but for programming language it thinks that it is object-oriented. It is storing and retrieving. It is objects, right? So in order to perform that conversion thing, from object to relational back to object, there are some certain intermediate software that is required, which is called the ORM, object relational mappings. So entity framework is one of the ORMs. Hibernate are one of the ORMs. So there are several ORM frameworks that are available. For Hibernate is for Java, entity framework is for C#.NET. So basically Postgres, Oracle database, they all use this kind of provide the extensions. Basically if you look at it, Postgres, Oracle, SQL Server, they are all RDBMS. But if they see a C# program interacts or a Java program interacts with them, like object, you store this object, they will be converted into tables and columns. Right? That's pretty much object relational model. Then semi-structured model, which is like modern models like NoSQL models, like they store data in JSON format or XML format. XML is slightly older way of doing things. JSON is more modern way of storing things. So again, when you have data which is not completely structured, we use semi-structured. Like I said earlier, we are only focusing on structured data. That is the reason we are going to learn relational database models and ER models. All these other models like object models and object relational models, semi-structured, hierarchical network, we are only learning now, but we are not going to use them much. We are not going to discuss this in this presentation. So that's about the semi-structured. Hierarchical model, in that, you have a tree-like structure. I'm going to show the picture of that. You will have an idea where there is a parent and child, all that kind of thing, one-to-many relationship. That's not how it is related. So it is actually pretty old model. We have storing things. IBM information management system like database management system uses this hierarchical model. Then network model. So it is more like a graph. So hierarchical is like a tree. Network is like a graph. So a child can have multiple parents, whereas in hierarchical one child can have only one parent. That's pretty much the difference between tree and graph, right? So integrated data store, IDS, CA, IDMS, these are the examples of a network model. So let's see a pictorial representation of these models. Relational models, you can see that there are tables and stuff like that. So there are tables, schema and all this. So what is schema? I'm going to talk about it in the next presentation. But schema. So everything is like rows and columns. That's the relational model. Entity relationship, you can see they're like a flow chart kind of thing, but not really flow chart. So you can see the elliptical things, rectangular things, 1 to n, m to n, diamonds things, all this. We are going to learn all those things in the coming presentation. So this is how you present interrelation. Again, this is only for representing the actual database conceptually. Once this is done, you create the other models like object relational or relational model, object oriented models or relational model. Mostly in this presentation series, we are going to talk about you create the ER model first, then convert it to relational model. Then object model, you see everything like a class object, right? So you can see that inheritance relationship and all that stuff. And object relation, again, you can see that there are tables and columns, but they are handled differently compared to the relational model when it comes to managing them. Semi-structured model, you can see that this is like a XML kind of or JSON kind of way of storing things, tags and values and all that stuff, right? Hierarchical, you can see that like there is a parent and child has, so there is only one parent. Every child has only one parent, right? So whereas in network model you have several nodes which are like connecting to each other like in different possible network paths and stuff like that. Again, we are, like I said earlier, we are going to discuss only about these two models, relational models. So these are for so basically these are the 7 most popular data model available that that we can use. So that's pretty much it. So for this presentation, so thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.